The creation of steel was a process that spanned hundreds of years. The first evidence of steel dates back to 1200 BC in the midst of the Iron Age. During this time period, iron was refined by rocks by heating them in air-enriched wood fires until they melted, separating the resulting liquid and then letting it cool, forming a solid. Iron was crafted into many things and had huge impacts, replacing bronze tools and weaponry with stronger iron ones. To increase the strength of iron further, blacksmiths like those in 1300 BC in what is now China heated iron bars and pounded on them with hammers, a process called forging. Forging hardened iron through a chemical process that wouldn't be understood until the 1800s, after the scientific revolution increased human knowledge of chemistry and metallurgy. It was discovered that iron bonded with carbon, which happened to be the primary makeup of the wood used to fuel the fires that iron was heated in, forming an alloy with enhanced physical properties called steel. 1,500 years later, China began to produce mass quantities of steel using massive fires and water power. Later, in the 1700s, steel manufacturing increased dramatically due to historic developments. These include the invention of the first successful steam engine, the development of the crucible steel technique, and the invention of the steel roller. These inventions allowed steel to live up to its true potential and be utilized in all sorts of places, even to light fires. Steel is the most important material for humanity and has revolutionized the world, which can be revealed by steel's crucial role in skyscrapers, ships, and machine tools.
Firstly, one must consider the ways in which steel served as the answer to a common problem within how people live their lives: lack of space. During the mid to late 19th century, cities throughout the world drastically increased population. According to Demographia, global cities like London and Paris experienced increases in population that were in some cases over 60% every 10 years, while other places like Beijing also served as prominent global cities. Thus, people's interest in places to purchase goods, live, and conduct business required accommodations considering their growing demand. With limited space to build in dense cities, a unique alignment of innovations was required to see the birth of the skyscraper. As buildings grew taller, a problem arose, however: transportation. Walking upstairs was inconvenient, so the most valuable floors in multi-story buildings were closest to the ground. Fast movement of people up and down the buildings was absolutely necessary, so Alicia Otis completely reinvented the elevator. According to HerculesLifting.com, primitive elevators were unsafe and undesirable because they were made out of wood and used hemp ropes that would degrade rapidly and often break, causing fatal injuries. It wasn't until Otis decided to use steel cables in steel elevator cars that the elevator allowed tall buildings to be desirable, thus enabling the skyscraper. To make construction of such structures possible, however, steel transformed the way buildings were built through its strength and eventual low cost. Steel's extreme rigidity and high tensile strength, combined with cities' solid bedrock, allowed for the construction of the tallest buildings in the world at the time. Various sources, including the Chicago Architecture Center, cite the very first skyscraper by modern standards to be the 138-foot Home Insurance Building in Chicago. It was 10 stories tall when built in 1885 and was the very first building to use a steel frame. This was a significant improvement over masonry buildings because although the demand for steel was not high enough at the time to make steel uniquely inexpensive, the structure was only possible due to steel's extremely high strength-to-weight ratio. Thus, the fact that skyscrapers came to be defined by their use of steel is a testament to steel's innovative strength for buildings and other structures. However, as more buildings utilize increasingly large steel frames and cores in cities throughout the world, steel increased its production and became even less expensive to obtain. Today, notable structures in the UAE, Malaysia, and China use even larger steel cores and frames to build structures over 2,000 feet tall, and future plans to build even taller structures utilize even stronger and more rigid steel. According to plans from MR Community Management, the Dubai Creek Tower, a proposed near-kilometer-high structure, uses steel cables to anchor the tower to the ground for structural support and design aesthetics, while other proposals utilize innovative construction techniques that use prefabricated steel columns to build planned structures nearing 3,000 feet tall. Thus, the use of steel in the past, present, and future as the gold standard for skyscraper frames since its conception, as well as its ability to enable and enhance other crucial skyscraper technologies like the elevator, has shown the value and major importance of steel in the context of architecture and living commercial and business spaces.
Ships have been used throughout human history, playing a key role in trade, warfare, and the spread of ideas. According to EVSmetals.com, steel was first created during the Iron Age. Meanwhile, wooden ships had been used for thousands of years, allowing people to travel the oceans, which cover over 60% of the Earth's surface, and made trade routes in places like the Indian Ocean possible. Because the Earth is covered by so much water, being able to move people and goods across it is absolutely essential for global trade. But why steel? Wood floats in water, metal sinks. Furthermore, mild steel corrodes in water, and even faster in the salty waters of the ocean, something that wood doesn't do. Given these arguments, it would seem that steel couldn't be the better than wood for shipbuilding, and is in no way fit to be essential for material for seamanship. Yet, according to history.navy.mil, over 99% of ships are made of steel today. Why is this the case? The answer: steel's benefits far outweigh its drawbacks. One key factor that contributes to making steel the most important material for humanity is its versatility. Many things can be added to steel to make it corrosion resistant, hard, flexible, or better able to withstand high temperatures. In addition, steel is incredibly strong. Seaflame.com claims that steel can range in hardness on the Rockwell hardness scale between 30 to 65 due to different alloys, a claim that is backed up by countless other sources. To put that into context, the hardest wood doesn't even register on the scale. In fact, an entirely different scale of hardness, the Janka hardness scale, is used for wood because it simply isn't hard enough to be measured in the same way as steel. Steel's vastly superior strength, as opposed to other materials, made it possible to make much bigger and more effective ships. The first steel warship was made in the United Kingdom in 1839, called the HMS Nemesis. By the 1850s, the United Kingdom made a fleet of steel warships, powered by steam engines. Nearly everything on these ships, from the armored hull to the guns and the motor, was made out of steel. History.navy.mil states that steel warships were not seriously adopted by countries like China until 1881, and the US by 1883. The UK used the first warships to control China's naval ports in 1842 and strengthened its control with its fleet of ships in the 1950s. Without these steel ships, the UK would simply not have been able to control the ports of one of the most consistently strong empires in world history. This is what allowed the opium trade to happen, which contributed to the Opium Wars, the Taiping Rebellion, the Boxer Rebellion, and later the fall of the Qing Dynasty in 1912. In this way, it is clear that steel has had immense impacts on world history, in ways no other material has had, making it clear that it is the most important material to humanity. In addition to warships, container ships completely changed trade by allowing extremely large amounts of goods to be transported at once, which had big advantages. Using one giant ship as opposed to many little ships is much more fuel efficient and requires far less labor, which was only possible because of steel's strength. These factors significantly reduce cost of transportation along with other steel-driven transportation like cars, trains, and trucks. As shown in this graph, global exports increased substantially at the same time that metal ships became the norm. With less cost, higher speed, and more efficiency, global trade skyrocketed in the 20th century. In this way, it is clear that steel played an essential role in globalization with respect to ship technologies.
Steel's ability to be formed in almost any shape imaginable is another key factor that makes it the most important material for humanity. Each new tool emerged to meet specific manufacturing needs, and innovations in steel components played a crucial role in their development. The lathe, often referred to as the mother of machine tools, has origins dating back to ancient Egypt around 1300 BCE. These early lathes were simple devices requiring manual operation of two separate people. Over time, enhancements such as the addition of a turning bow by the Romans improved their functionality. The significant leap came during the Industrial Revolution, when precision metal cutting lathes were developed using steel due to its strength and durability. According to Tramar Industries, 1868 saw the first air-hardening tool steel, which was developed by adding tungsten, resulting in a material that hardened upon cooling in air. This steel was more durable and wear-resistant, making it ideal for cutting tools, while also leading to the development of high-speed steel in the early 20th century. Bavia Machine Tools brings the separate innovations like the slide rest to light, which allowed for more accurate and efficient metalworking, laying the groundwork for modern lathes which use high-speed steel as their main component. Similarly, the milling machine emerged to address the need for producing complex parts with high precision. In 1818, Eli Whitney developed one of the first milling machines to manufacture interchangeable musket parts, revolutionizing the production process. Subsequent improvements brought steel parts to milling machines, allowing for faster and easier production while also allowing harder metals to be milled. Press machines have also evolved since their inception. Early metal presses, such as those used for coin minting in the 1500s, relied on screw mechanisms and manual force. The 19th century introduced various types of presses, including the eccentric and steam presses, though the greatest advancement was the invention of the hydraulic press, which utilized steel in the cylinders and arm, greatly increasing the strength and reliability of presses and revolutionizing manufacturing. These advancements in steel and machine tool design led to equipment that was stronger, more precise, and longer lasting. Modern lathes, mills, and presses can handle higher stresses and maintain accuracy over extended periods, reducing downtime and improving productivity in manufacturing environments. Through machine tools, steel has played a crucial role in making nearly every complex part. In this way, it is clear that steel is the most important material for humanity and has revolutionized the world in a way no other material has.